Hello, everyone. So let me start our new chapter, production. Welcome to chapter 6, production. Until now, we studied, do you still remember? Okay, we studied consumers, right? How people decide what to buy. Now we switch sides. We study firms, how businesses decide what and how much to produce. All right, so we have 4 sections today, but today I only cover 2 of them, okay? 6.1 and 6.2. 6.1, firms and their production decisions. Basically, this section is trying to answer that what questions does a firm need to answer to run a business? Okay, and next one, 6.2, production with one variable input. So here is labor. We assume that if a firm can only change one thing, like how many workers to hire, how does output change? All right. Next section, production with 2 variable inputs. So here is like, what if the firm can change 2 things? Let's see, labor and machines. All right. So they can change 2 of them. What is the production? And next one, 6.4, which is returns to scale. If a firm doubles everything, workers, machines, materials, does output also exactly double? Maybe more, maybe less, we don't know. So we call it returns to scale. Okay? So simple example to keep in mind throughout. Imagine you own a noodle shop. Your inputs are workers and cooking equipment, right? Your output is bowls of noodles. This chapter is about the relationship between how much you put in and how much you get out, okay? Inputs and output. Okay, so we've been on the demand side, which is consumer, right? Now we switch to the supply side, producer, right? Or firms. So here I showed you that we will see how firms can produce efficiently and how their cost of production change with changes in both input prices and the level of output. All right, so let's look at the theory of the firm, explanation of how a firm makes cost minimizing production decisions and how its cost varies with its output. So it's just about how a firm decides how to produce at the lowest possible cost, right? Cost minimizing. Okay, so firms make decisions in 3 steps, very similar to how consumers made choices in earlier chapters. I hope you can match them. It's actually they have the same logic. All right. So first one, production technology. What's physically possible given workers and machines? How much can you actually produce? Next one, cost constraint. Remember, consumer has budget constraint, but for producer, they have cost constraints. Why? Because firms don't have unlimited money. They face a budget too just like consumers, right? The next one, input choices. Given technology and cost limits, what's the best combination of labor and capital to use? Same logic as consumer, right? Goods choice, how many goods will they buy, right? Remember we have two goods, X and Y. So here for the firm, we have two inputs, labor and capital. So please keep this parallel in mind. Consumers choose the best combination of goods given their budget. Firms choose the best combination of inputs, labor, capital, given their costs. Same logic as I mentioned before, but different side of the market. Okay, let's start with the first section, firms and their production decisions. Okay, the first one. The question is that why do we even have companies? Why don't people just work independently and sell their own labor task by task? So the answer is coordination. All right. Imagine building a restaurant if every single task, chopping vegetables, cooking, serving, washing dishes, right, required a separate negotiation and separate payment every single time. Extremely inefficient, huge waste of time. Instead, a firm solves this, hire workers on salary, and a manager simply directs what needs to be done. No need to negotiate every task. The worker already agreed to follow instructions in exchange for a fixed salary. Okay, so let me give you a local example. Think of a Thai restaurant. The owner doesn't negotiate a new price every time they ask the cook to make one more dish or ask the server to clean one more table. Everyone's on salary and the owner just coordinates the work, okay? Coordinates. That's the basic reason firms exist. They save everyone the cost and hassle of constant bargaining. All right? So they can avoid this kind of bargaining. Next one, to produce anything, a firm needs inputs, right? We call this factors of production. Mainly we have three types, right? So let's see the official definition here. What is factors of production? Inputs into the production process like labor, capital, and material. Labor, just think about the people, right? Workers, engineers, managers, right? Sometimes, the entrepreneur's efforts of the firm's manager. Next one, materials, the raw stuff that gets used up, steel, water, electricity, everything that you need to run a business, all right? Those kind of materials. Next one, capital, which is the long-term stuff, okay? Land, buildings, machines. Okay, let me write it down. Basically, capital refers to the long-term stuff. Okay, like land, buildings, and machines, right? Simple way to remember. Labor, the people. Materials, things you use up. And for capital, which is the thing you keep and reuse. All right. Next one is the production function. Let's see the definition. Function showing the highest output that a firm can produce for every specified combination of inputs. Okay, so basically, the function shows that the highest outputs, right? So basically, we have Q. This is the output, is a function of K and L. K, which means capital, okay, L means labor. All right. So in plain words, it means that if you give me this much of capital, which is K, and this much of labor, which is L, here the maximum output Q you can produce. All right, so Q is the maximum output. It assumes that firm is using inputs efficiently, means no waste. Okay, efficiently, all right, no waste. Think of it like a recipe, all right? We have inputs in, output out. And this function tells you the best possible results. Now, short run versus long run, okay, not about calendar time, it's about flexibility, right? Short run, period of time in which quantities of one or more production factors cannot be changed, which means that at least one input is fixed. Okay, this is a short run. You are stuck with it. You can't change it quickly. All right, so the example is that a noodle shop can hire more workers this week, but can't build a bigger kitchen this week, which means kitchen size is the fixed input. All right, that's why we have fixed input, production factor that cannot be varied. And then for long run, amount of time needed to make all production inputs variable, all right? So in the long run, all inputs can change. Given enough time, the shop can expand the kitchen by more equipment. Everything becomes flexible. Okay, so one line takeaway. Short run, something is locked in. Long run, everything is adjustable. Next one, 6.2. This table is very important. Okay, very important. So now, okay, production with one variable input. Okay, so we have labor. We now assume that capital K is fixed at 10. You see here, all the way around is 10. So which means this is short run. And we only change labor, right? We only change labor. You see, labor is changing. This table shows what happens to output as we add workers once at a time. Let's define three things. First one, total output, which is Q. All right, think about the total bowls of noodles produced. And then we have average product. Okay, you use Q divided by L. So this means output per worker, total output divided by number of workers. Next one, marginal product. All right, delta Q over delta L, which means the extra output from adding one more worker. Okay, let me repeat. The extra output from adding one more worker. So look at the pattern in marginal product. We have 10, 20, 30, 20, 15, 30, 4, 0, -4, and -8. Have you noticed that it goes up first from 10 to 30, then starts falling from 30 to 0, right? And then eventually turns negative, all right? So this pattern, rises then falls, is called diminishing marginal product. Let me write it down. Okay, diminishing marginal product. And it's one of the most important ideas in this chapter. We'll see it on a graph next. So here, I want you to focus on several points. Let's see at point when labor is 2. Okay, so total output is 30, average is 15, and marginal product is 20. And also 3. Okay, let me highlight them. And then we have one more, which is at labor equal 8. All right, marginal product equals 0. Okay, just remember those several points because I'm going to show you next. Okay, so this slide just confirms the two definitions from the table. What is average product? Output per unit of a particular input. Okay, so Q over L, which means on average, how much does each worker produce? And then marginal product. Okay, additional output produced as an input is increased by 1 unit. Okay, so we have this formula delta Q over delta L, which means how much extra output does the next worker add? And one important point, marginal product isn't fixed forever. It depends on how much capital the worker has to work with, okay? Same worker, more machines to work with, likely higher marginal product. So here, marginal product isn't fixed forever. Let me give you a simple example. One noodle cook with only one stove can only cook so fast. Given that same cook, 3 stoves, and their marginal contribution goes up, they can now produce a lot more. Okay, so marginal product of labor is always tied to how much capital is available. Okay, so those graph is very important. Okay, this graph is very important. So I'll mark it. This graph shows the same data from table 6.1, but now visually, okay, visually, 2 panels, okay, top and bottom, top and bottom, right? stacked so they line up. I'll give you some minutes. Please, can you try to read those two graphs by yourself? Okay, let's look at the top one, which is A. Total product curve. This is just total output as we add more workers. Notice the shape. Rises steeply, then rises more slowly, eventually flatten, and even bends down. Okay, this is the total product. The bottom graph, average product and marginal product curves, okay, built directly from the slope of the top graph. Let's carefully match the points to table 6.1 data. Point A, we have 2 workers, right? And the total output equals 30. Okay, you go back to table 6.1. Okay, so please emphasize those several points. And the tangent slope, which is marginal product at L, equal to, okay, so you need to look at the bottom, which is, what is the marginal? Remember, this is the marginal, okay? This one is the marginal product, and this is the average product. Okay, so let's look at here. You see, the marginal product is 20, right? At point A. And let's see point B. We have 3 workers, and the total output is 60. And here, line from the origin to B has slope. From here, this is the origin, right? The line from the origin to point B has slope, which is 6/3, right? This is the total output, 60/3 equal 20. So this is the average product, right? You look at here, which is this point, is 20, right? And next one, point C. You see point C here? We have 4 workers. Total output, let's see, is 80. Okay? And the line from origin to point C. So basically, you connect the origin and the point C. We will have the slope, which is 40. Because you use 80 over 4. Sorry, equal 20. Okay, where's 20? Okay, this is 20, so it's still, this is both the marginal product and average product, okay? Because at this point, MP intersects with AP, okay? So here, marginal product, let's see here, marginal product rises, then peaks around L equal 3, which means NP equal 30, then decline until L equal 8, which is 0, NP equals 0, right? And then becomes negative. And average product peaks slightly later, around L equal 3 or 4, which means average product is 20 and then decline. Okay, marginal product crosses average product exactly at average product's peak, this point. This relationship is always true and is the safe, reliable takeaway for the graph, regardless of exact point location. So basically, you need to know how to draw your total product, okay? Rise steeply and then rises slowly, flattens, and eventually bends down. This is the total product. And for marginal product, okay, rises and then at the peak decline, eventually negative. But for average product, okay, rises later and the peak is intersect with marginal product, okay? So this is the peak for average product, okay, rises and then falls. Next one, still, let's finish reading this graph carefully. So here we have two new points, E and D. All right, so look at point E. The bottom graph, this is where marginal product and average product cross each other. Okay, so at point E, MP equal AP. Okay, and to the left of point E, marginal product is above average product. That's why this pulls average product up. Okay, so let me write it down here. MP is greater than AP. So we have average product rises. Okay. To the left of E, okay, left side of E, marginal product is below average product, which is less than average product. Okay, this pulls average product down, right? You see here. So point E, where NP equals AP is exactly where average product switches from rising to falling. That means E is the peak, which means maximum of the average product curve, okay? So here, average product reaches its maximum at point E. And next one, let's see point D, the top graph, okay, point D. This is where total output is maximum. The very top of the total product curve, right, at the peak, the curve is flat, right? You see here, this is flat. And so the tangent line's slope equals 0. What is the slope of total product? Which is the marginal product, right? So which means here, at this point, point D, the slope, MP equals 0. And then you look to the bottom, okay, at when L equal 8. Right, this is the marginal product. And at here, when L equal 8, MP equals 0, right? Okay? So marginal product equals 0 at point D. Let me summarize. E equals average product peak, where MP cross AP. D, total products peak, where MP equals 0. Two different peaks, okay, two different meanings. Don't mix them up. So when you draw those graphs, you should clearly show me that at point E, average product, okay, meets, sorry, again, at point E, average products peak. That means this one is the maximum average product. But at point D, total products peak, all right? And when total product is maximum, MP, marginal product, equals 0, you need to show me that marginal product equals 0 exactly, okay? So those are the explanations for figure 6.1, but actually I already explained it to you. You can read it by yourself, okay? Basically, they are what I covered already. Okay, let's move on. This slide is just a clean summary of two rules we already found. Okay, let me help you. In general, the average product of labor is given by the slope of the line drawing from the origin to the corresponding point on the total product curve, which is here, right? From the origin to the corresponding point, like C, okay, you connect OC. So this is the average product. Okay, you use 80 over 4 equal 20. Basically, this one is Q over L, right? This is AP. Okay, let me repeat again. Average product at any point, which is the slope of the line from the origin to that point on the total product curve. But for marginal product at any point is the slope of the tangent line at the point on the total product curve. Okay, it's the slope of the total product of the tangent line. Okay, so here I showed you the slope of the total product. All right, and here is their relationship between average product and marginal product. Okay, so here you see when the MP is greater than the AP, the average product is increasing, which is here, right? MP greater than AP, AP is increasing. And then at point C, basically, yes, it's C, okay? C, point C is corresponding to point E. At this point, MP equal AP, okay? You see AP and MP are equal. And then from C to D, all right, you see from C to D, which is this part, MP less than AP, okay, AP is decreasing, see here. the marginal product falls below the average product, you can check that the slope of the tangent to the total product curve at any point between C and D is lower than the slope of the line from the origin. Let me help you. The slope of the tangent to the total product curve, which means NP, right? This is NP. And then the slope of the line from the origin, which is AP. So just basically, this means that NP is less than AP. Okay, I showed you here. You see from point C to D, NP is less than AP. Okay, and AP is decreasing. Let me repeat. This graph is very important, okay? This page, actually they're the same graph, okay? Figure 6.1. This graph is very important. All right, so this just restarting what we saw visually. Marginal product always cross average product exactly at average product's highest point. No math here. Just make sure the logic is clear before we move to the next section. Next key law, diminishing marginal returns. In plain words, if you keep adding one input, which is labor here, while everything else stays fixed, eventually each additional unit addresses less and less extra output. I already showed you in table 6.1. Here, right? Rising and falling, eventually negative. This is the diminishing marginal product. And also this is the diminishing marginal returns, okay? Diminishing marginal returns. Okay, let's see the official definition law of diminishing marginal returns. Principle that as use of an input increases with other inputs fixed, the resulting additional to output will eventually decrease. Okay, and here we have an important clarification. Be careful. Diminishing return does not mean technology can't improve productivity over time. Look at figure 6.1. Okay, so we have three different curves, O1, O2, and O3. Each curve individually still shows diminishing returns, all right? Each curve, okay? Which means output rises then flatten. But O2 sets above O1 and O3 sets above O2, meaning at the same number of workers, later curves produce more output. Why? Because, because there's better technology. Because better technology, that's why from point A to point B and also to point C shows that output keeps increasing over time, all right? You see here, because of technology improvements, better machines, better methods, right? So diminishing returns happens within one technology level, but new technology can shift the entire curve upward. Let me help you with this. Diminishing marginal returns happens within one technology level. That means new technology can shift the entire curve upward. All right, so that's why OE to from O1 to O2 and then to O3. Okay, this is because of technology improvements. Okay, here, labor productivity. What is labor productivity? Average product of labor for an entire industry or for the economy as a whole. All right, so here, labor productivity is just the average product idea we already learned, but applied to a whole industry or a whole country, not just one firm. So why does this matter? Because there's a direct link between productivity and standard of living. Okay? So let's see here. Consumer in the aggregate can increase the rate of consumption in the long run only by increasing the total amount they produce. Understanding the causes of productivity growth is an important area of research in economics. We do know that one of the most important sources of growth in labor productivity is growth in the stock of capital. What does it mean? Which means in the long run, a country can only consume more if it produces more, right? You can't have everyone earning higher wages and buying more stuff unless the economy is producing more total output. There's no shortcut. Okay, so what drives productivity growth? There are two main things. Let me write down the question. What drives productivity growth? Okay, so actually the first one is the stock of capital. Total amount of capital available for use in production, which means more or better machines, buildings, tools available to workers, more capital per worker. Of course, we're going to have higher output per worker. And next one, technological change. Okay, new inventions, better methods that let the same input produce more output. Okay, so development of new technologies allowing factors of production to be used more efficiently. Okay, because of the technology. So let me give you a simple example. Think about, okay, there's a farmer. And before, a farmer with just a hoe. So what is a hoe? It's the tool for digging. So before, a farmer with just a hoe produces much less rice than a farmer with a tractor. Okay, so basically, same person here, but the capital they have access to completely changes their productivity. That's the connection between capital, technology, and a country's standard of living. Okay, so today I'll just finished here. Okay, let me mark it. 27 July. Okay, so just half of chapter 6 production. Um, I hope you enjoy this video and don't worry about, I would say don't worry too much about your midterm exam because we still have 2 weeks for teaching. So before the midterm exam, I will explain the homework to you. Okay, I'll explain you the homework from a midterm exam step by step. But basically, I already told you that what is the knowledge that you should emphasize. Okay, I don't want to talk much here. I finished my part today, so thanks for watching, and I'll see you. All right, I'll see you next month, which is next week. Okay, the 3rd of August. So please enjoy your holiday and please watch this video as well. Okay, so bye bye.